Anytime I'm hearing someone talking about JSON, this is the picture that comes in my mind first. But in computer environments, JSON is a document format. First of all, it is an abbreviation. It stands for JavaScript Object Notation. It is a very lightweight format. It is text-based. So it is used primarily designed for data interchange. And it is a document format. That means you can store those JSON documents as files. Originally designed, JSON was originally designed to persist JavaScript objects. And there are two standards. One is JSON.org and the other is the ECMA 404. That doesn't mean standard not found, but this is the actual number. And if you download those slides and click on those links, the links will are linked direct to those standards. So if you are interested reading about the standards, just do so. Okay. So as I mentioned, JSON is a very simple format. It has to be because the originally target group back in the 90s were a web designer who thought that HTML is a program language. So those are the target group wasn't that that deep into programming and all this kind of stuff, and that left us with a very simple format, which is good because it's very easy to understand. Basically, JSON consists, or JSON documents consist of two structures: the unordered collection, those are key value pairs, separated by commas, and you enclose them in curly braces, those thingies here. If you are familiar with other program languages, those are realized as objects, records, structs, dictionary, hash table. Those map to unordered collections in JSON documents. And we have ordered list of values. Those are, again, separated by commas, and you put them in square brackets. And if you do this, you have an array in other programming languages. The important thing about arrays in JSON is that they are ordered, which means the sequence of those elements is important. If you change the sequence, you will get another JSON document. And we will have a look at that, at an example of that later on in this talk. JSON can deal with a couple of data types. The mostly used will be string, and strings are always enclosed in double quotes. Then we have numbers. You can use integers, floats, or the scientific notation with the E, and all those are valid, and numbers don't have to be in double quotes because they are a data type of their own. Boolean data types, true, false, and null, don't have to be quoted again because those are keywords. And then you can have objects. Those are nested key value stuff, and you can nest objects or arrays. And we have arrays, and those can consist of simple types or objects again. So we have an example on the left side here. I have nested an object, so the collection consists again of a JavaScript document and JavaScript object, and we have an array, and here we have simple types 1 and 2, and 3 again is a nested object. Okay. What is left to say about JSON documents? First thing, JSON documents are per definition always encoded in Unicode, in UTF-8. Numbers are encoded in the English format, so we have to use a decimal point, not like we Germans a decimal comma. White space is widely ignored, so you can use as much or as little spaces, line feeds, tabs as you wish. Dates are represented as strings. Usually, so dates are just strings. It has become a web standard, which is not standardized, but it has become a standard to use the ISO 8601 Zulu time format. And I have an example right here. So this means 4-letter year, 2-letter month, 2-letter day. divided by T for time, followed by the time, and then the Z for Zulu, which means dates in JSON document are expected to be in UTC time. And JSON is schemaless, which means any given valid, syntactically valid JSON document is a valid JSON document. Other than, for example, XML, you cannot check JSON documents against a schema or a kind of stuff. Although there are a couple of implementation of those schemas, but those are not in the standard right now. So you can't expect that anyone follows those schemas. Okay, so how do we store JSON in the database? First of all, JSON documents are text documents, so we are using text-based columns. Typically, you will use varchar2 columns or CLOC columns, or even better, blob columns. The blob eliminate the national language support layer, so there don't have to be any NLS conversion to occur, because the database knows that JSON documents are always in UTF-8. This works well since Oracle 12.2 and 12.1. There were a couple of problems with that. And the important thing is that the database should be in the UTF-8 character set, AL32 UTF-8, to deal with those JSON documents right. You can put a check constraint on the columns here where you want to store your JSON data. That is JSON, and you can use that for sanity, so that the database makes sure that only valid JSON documents are stored inside these columns. And it enables the dot notation for querying, and we will have a look at that in a couple of slides. If you are happy enough to use Oracle 20C already, there is a new feature that is called binary JSON storage, which is a new data type and stores by JSON in a compiled binary way, which makes querying and all this kind of stuff way faster. Talking about querying, how do we speed up the querying of JSON documents? So imagine the statement here: select star from departments_JSON, where JSON value, and JSON value is a new function introduced with Oracle 12.1. Department data, which is the column that stores the JSON document, and then we give a JSON path and say sales. By the way, whenever you see me give you an example referencing to a table departments_JSON, I took that from Chris Saxon's excellent blog post, how to store, query, and create JSON documents in the Oracle database. And you can click on this link below here, and it will guide you, it will lead you to those blog posts, and you can read all the details about these examples here. But for now on, okay, so we want to execute this query. We can put a function-based index on these department data column, and this is very useful when searching for a specific attribute. So how do we do that? We say create index name on departments JSON, which is the table, JSON value, and then exact this expression here. And this will speed up the query a lot, but only query on this, only queries on this special field inside your JSON documents. If you want to speed up the searches in general, you want probably to use a search index, and search index using Oracle Text. Oracle Text is a cost-based option for the Oracle database, but for the purpose of searching JSON, it comes for free. So you can use this without any license costs. And the search index can be used for the functions JSON value or JSON text contains. So you can do free text searches. The important thing about that is that it indexes the whole document for every row. So those search indexes will be way bigger than the function-based index, where you index only special fields inside your JSON document. So this is the syntax. We say create search index for JSON. And this generates an Oracle text index, especially for those JSON searches with no additional license fees. And then we can use this as we like. JSON text contains, and the query is very fast after that. So one important question that customers ask me quite often, and even colleagues, when do I store JSON documents inside the database? So I store those JSON documents inside the database whenever I need the original document for reference. So we remember the JSON documents are used for data interchanging. So it's an interchange format for using for interfaces. Yeah. So we are storing the original JSON documents when we need them for reference, when we want to archive them, or when we want to redistribute them. So give them again to different customers or different computers or whatever. But you have to, and another reason for storing those JSON documents is that the JSON structure can vary, and JSON documents can store much more information than we originally need in the first place. So if you want to reference or to query those documents later on, then it is a good idea to store those JSON docs inside the database. The other question is, when do I convert JSON to relational data? So we have to think about that. We are working inside a relational database, and the strength of these databases is storing data in tables and relations. So when do I convert those JSON documents to relational data? The answer is very simple. So whenever I need to work with the contents, to query them, to reference them, to do stuff with them, and we're thinking about JSON is an interchange format. So this means almost always. So whenever I'm loading JSON documents inside the database, the first thing is I'm parsing them, and I'm splitting them, and storing the contents of the documents inside relational table. Yeah, so this is the animation. Sorry for that, the animation is broken, but I talked about all this kind of stuff. So how do we get JSON inside the database then, those JSON documents? Well, this is very simple. We remember JSON documents are text. Insert and update works fine as long as the document size is smaller than 4,000 bytes, or the new limit 32,000 bytes if you have enabled this. And you can put this is JSON check constraints, which will reject all non-JSON text inside those columns. So you can always say insert, and this will work very fine. The util cast to raw here is used because the data type of this column is a blob. So it's not a CLOB, it is a binary blob, so we have to cast to raw. And this is the reason for that. Another very good and very fast way is to use external tables or the SQL loader. Usually you will receive JSON files as JSON dump files. Especially when those are exported from JSON doc databases by NoSQL databases like MongoDB. And MongoDB produces those JSON dump files. And those JSON dump files contains lots of JSON documents, and every JSON document is in a single row. So you have lots of documents, each of them in a single row. And the SQL loader and external tables can deal perfectly with data that comes in row-based in single rows. And this is the syntax for creating an external table. So we say create table, organization external, type Oracle loader. This is my directory where the document resides in. These are my access parameters. So the records are delimited by hex value 0A, which is the line feed. And this is my fields with JSON document and raw. And you can load this in parallel, and this will load those documents very, very fast. Okay. Finally, there are a couple of other ways. You can always use client tools like your own written Python script, or if you're familiar with SQL CL is the SQL Developer command line. So this is basically from Oracle SQL Developer, the worksheet turned into a command line tool, and it has a very cool a very cool enhancement where you can script in different languages, and for example in JavaScript. And this is an example of a JavaScript that runs directly in SQL CL and loads a binary and blob into the database. So only a couple of lines, and then you can load using SQL CL, so using an Oracle tool, client blobs that are resided on your client computer inside the database. And I have a complete talk about this topic, and if you check my website, you will find this talk, and you will find even a video about this talk, and there I'm explaining how this is going to work in general. So finally, there's another way to getting JSON documents into the database, and that is the REST services. JSON is an interchange format which is used in the web world a lot, and REST interfaces are very common in the web world, and luckily for us, we can turn the Oracle database into in REST server very easy by using the Oracle REST data services, or short ORDS or RDS. It is free, it is Java based, evolved from the Apex listener. So if you happen to have Apex installed and up and running in your database, the chances are very, very high that you have a configured and running ORDS as well. And then you are ready to go and use this ORDS listener as a listener for Oracle REST services. You can very easily REST enable the database by using SQL Developer Wizard, or calling a couple of PL SQL AP call, doing a couple of PL SQL AP calls. The good thing is those Oracle REST services are pure metadata stored in tables inside the ORDS schema in the database. And you can develop and deploy those services in a couple of minutes. There is a very good very good blog post by Jeff Smith, the product manager of SQL Developer and this REST services, and you can and he shows you how to load a blob in a table via REST within really a couple of minutes, and you're good to go. It's quite simple. Just to show you how simple that is, this is a screenshot of SQL Developer, and I have the REST the REST data services module from SQL Developer Club on the left side here, and this is all code you need to implement those REST services. So just a bare insert using the body, using the those variables with the columns here. I'm missing the name. Okay, using those variables, and you can just insert those stuff into the database. Okay, the other way around, we can the JSON database, the Oracle database is able to do HTTP requests by itself. So you can use the package UTL HTTP. You have to enable that to allow the database for network access. This is very important for security reasons. If you want to query HTTPS REST services, you will have to put a wallet up in place. Once this is configured, it works very smooth, very simple out of the box, and you can straightforward implement REST calls to query REST interfaces and load JSON documents into your database by yourself. Okay, so now we learned what JSON is and how to store them in the database, when to store them and how to store them in the database. So when I have a JSON document inside my database, how do I query it? And before I show you how to query them, we have to have a little look on the JSON path. JSON path is XPath from XML for JSON. It is used all over the place on the web and in the Oracle database. It uses a very straightforward dot notation. So you say the $ reference is your current document, store.book.title, and you get this value. It returns a JSON document or a single element. And the good thing is there is a JSON path online evaluator available on the web. And I think we have the time that I can click just here. See this website that is jasonpath.com. The very good thing, this all happens on your client side, so no JSON documents are transferred over the internet, and you can put a JSON document on the input side and can just try out the JSON path syntax. So this expression here queries the phone number, the $ is the document phone numbers, the first element dot type. So let's have a look. Phone numbers, first element, type is iPhone. Let's see if we can get the number as well. Number, and here we get the number. And using this tool, you can build your JSON path expressions very easy, very straightforward. And this helps me in my personal developer life a lot. So these are the syntax elements. Only a very this is very limited. You have only a few of those elements, and yeah, too fast. So, and this is a couple of explanations. So what when you type this on the left side, this is what to expect. I'm not going over this in detail. I leave that for you for studying if you want to, and for reference on this slide here. And let's see how we can really query a JSON document right now. Hold on. So if we say select departments data.department. Important thing is that the dot notation only works if you prefix those columns with a table alias. So you have to use table aliases. This is why I marked those in yellow here. And this is another example. So this is an example how this works. We say select department. Sorry, can you see my mouse? Yeah. Select department data employees. The first element of the employees array.name, and this is where the department is 110, and this is what we are getting here. If we say, okay, if you put a star instead, reference of the first element, we are getting a JSON array back because there are more than one employees in this department. Again, I put these examples from the Chris Jackson blog post, so you can read all the details here. And if you want to use the dot notation, your column needs is JSON constraint. Otherwise, this won't work. Or you can use the new treat as JSON function in Oracle 18. So if you are happy enough to have an Oracle 18 database around or newer, you can say, you can put this in a with clause and say, treat this column as JSON. So this eliminates the need of is JSON check constraint. Okay. Typically, you will use the JSON table operator. I'm using that most of the time because this is the most powerful operator to deal with JSON documents. The good thing is the JSON table operator lives inside the SQL from clause, and it produces rows and columns. So this is one of the very rare functions inside the Oracle database that uses some takes some text and produces rows and columns out of it. It accepts lobs, C-lobs or B-lobs with JSON data or varchar columns, whatever. And the definition and the syntax is included in the SQL 2016 standard. So the JSON table syntax works the same way on different databases. As far as I know, it is currently implemented in Oracle, of course, and in SQL Server and in IBM DB2 and a couple of other databases. So this is a very simple example of how JSON table is used. So we have our JSON document here. So we say select column name from JSON table operator lives in the from clause. From, this is our JSON document here. You can put a column there if you like as well. So I have a literal value here. The next operator produces your rows. So we are saying, give me a row for every element inside this array here. And then we have the column expressions, and there we say, okay, give me a column, or generate me a column called Wert, which is the German word for value. The data type and the path. So the path is very simple. Just give me the document back here. You can have as many columns as you wish, depending on this on the structure of your JSON document. And if you execute that, this is what we get returned. You can see this is very, very fast in execution. So it looks absolutely and behaves absolutely like any other table inside the Oracle database. So you can join them, you can do all kind of stuff with them. With the columns, you can use all SQL functions, or whatever you like. So remember that I told you in the beginning that JSON dates are usually stored in ISO 8601 format. And converting those strings in Oracle is a little bit tricky. So you have to, the first thing, we start on the inside. The first thing is I'm converting this string to a date by omitting the time zone, so by UTC date. Then I'm converting it back to a string with the time zone code that Oracle can use, and then I can use the to timestamped with time zone function to convert it to Oracle timestamp with the correct time zone. And even Oracle noticed that that is a little bit tricky and complicated. And so in Oracle 18, there was a new date function select, which is called toUTC with timestamp and time zone. And this new function happens to be available in Oracle 18, except those JSON style date formats. And this is very much simpler than this one above. Okay. So how do we work with JSON inside the database? How do we compare JSON documents? Luckily for us, Oracle has implemented a function JSON equal. And JSON equal compares two JSON documents logically. So it parses the content of those documents and compares them logically. So if you have a look of those two JSON documents here, the first is that one, 1, 2, 3, and the other one is formatted quite different. And JSON equal parses those and compares the contents. And the result in this case is those documents are equal, because JSON documents, in JSON documents, white space isn't important at all. And the order of those elements inside the JSON document isn't important as well. Those are unordered lists. If you remember on the first slides, you can put those JSON objects as unordered lists. So the order of those elements doesn't count, and therefore those two JSON documents are equal. If we have a look on this example here, again, this looks pretty much the same. So we have two JSON documents that look pretty much look alike. But if we ask the database with JSON equal, it says those documents are different, because if we remember the order of the elements inside an array, this array here, This is an arrays are ordered list. So in this array, the order of the elements is important. And if there's not the same in two documents, those two documents aren't equal. And I personally love those functions because it is a hell to implement this kind of stuff yourself in PL/SQL or whatever, as you can imagine. So if you want to update JSON documents inside your database, you can use the function JSON merge patch, which is a new feature in Oracle 19. And that helps you to update, delete, or even create JSON documents. And it works a lot like the Unix patch or SQL merge command. So let's have a look at example. JSON merge patch. So from the first argument is the JSON document. So this is my JSON document, first name Eric, last name Cartman. And I say JSON merge patch and give another JSON document inside. And the result will be an updated document which updates the content of the object of the key value pair last name from Cartman to Fox. Next example. Call JSON merge patch with a JSON document that contains a field that isn't in the original document. So first name Eric, last name Cartman. Add this field salary, and this is the expected result. So we get this new field added. And if you want to, if you call these the same document with first name is null, we will receive the JSON merge patch will delete the first name field from the JSON document. Okay. So how do we generate JSON in the database? There are a couple of SQL functions available starting with Oracle 12.2. Those functions are called JSON object, JSON array, and JSON array egg. Those are SQL functions, so we are using them in the in SQL statements. And if I say, okay, JSON object, and then give just a couple of fields here, I will receive a list of, I will receive a JSON document for every row inside my customer table. And this is very simple and very straightforward. JSON array will receive me, will generate me JSON arrays for every row inside my table. And I can say JSON array egg. This is an aggregate function. And I can nest those functions. So I can say JSON array egg and call JSON object inside. And then I will get a single JSON document which has aggregated the values of all those lines returning from my query here. And so because this is an aggregate function, I will receive only a single line. And again, you can nest those functions as you wish and can use them to generate complex JSON documents from your SQL queries. Okay, so now we have generated those JSON documents in the database. How do we publish them? How do we get them outside to the other systems? There are quite a couple of methods available here. First of all, of course, we can use the good old util file to let the database write those files. Those files will be reside in directories accessible to the database, so typically on the database server. We can use client tools like SQL Plus or SQL CL to spool our files or script our JSON docs in modern languages when using SQL CL. And this is probably the version, the method of choice in the web age. We will publish them using a REST service. You remember we have the ORDS, the Oracle REST Data Service available, and that lets the clients request the documents on demand whenever they need them. And we are delivering them via HTTP or better HTTPS. So I'm at the end of my, near the end of my talk. The topics we cover today is what is JSON, how to store JSON content and when to store JSON documents and when to store relational data, loading JSON into the database, querying JSON, manipulating JSON, generating JSON, and publishing JSON. What I didn't mention at all is the PL/SQL APIs that are available inside from PL/SQL. You can generate PL/SQL documents using PL/SQL functions. There is a very cool function which desires a talk of its own because it's a little bit complex, that is called JSON Dictionary, that lets you query information about the JSON documents and generate virtual columns for your tables. This is a very cool and very convenient feature, but it is that complex that you need a whole talk on this for its own. And finally, there are JSON packages inside Apex. Those are available for quite a long time. You can even use them with Oracle 10 or 11. And you can use this as well to generate JSON documents inside the database. Okay, so JSON is a very flexible interchange format. It is the lingua franca of modern web apps. So virtually every web app around there talks JSON when they're interchanging data nowadays. Loading JSON into the database is very easy because it is just text, and it is and the database deals with it as just text. The JSON features evolve very quickly about the database. So the JSON was introduced in Oracle 12.1, and every new database version has become new features. Have a look at Oracle 20c, where we have the JSON data type. The database can be turned into the backbone of RESTful services very easily. And I encourage you to do this because this makes this is very easy and makes the Oracle database part of those web applications. Yeah, again, my animation is broken. Sorry for that. So what is left to say? Please do try this at home, play around with this JSON functionality and start using it. And that's it. I'm done. And we have a couple of minutes for questions, I think.
Robert, thank you for being with us. There's one question from Slobodan.
I just saw that there are a couple of questions. So the first question is, will presentation or recording be available after webinar? I think these sessions will be recorded and available. Is so? Okay, so then we have another comment on this presentation. Slobodan says, nice presentation, thank you. I'm forced to use old database versions. I'm using mostly Apex JSON package. Yeah, this is absolutely fine. I did not have the chance to dive deep into it, so powerful built-in packages. Those packages are very powerful and very good and available in newer versions only. Sorry for that. Okay.
Thank you, Robert, for your presentation. I hope we will see you in EU in Tajikistan on our future events. Welcome.
Of course. If you choose my presentations every time. Thank you. Bye then. Bye from Frankfurt.